Hi everyone. So the next topic is a recursion. So what is actually recursion? Not only in Java, so we heard about this word in C also. So the process in which a function calls itself either maybe directly or indirectly, then that is called recursion, where the corresponding function, so what is the function involved in this process, is called as a recursive function. So this is the one definition. We have another also. So recursion in Java is a process in which a method calls itself continuously. Okay, so a method in Java that calls itself is called as recursive method. Okay, this is another definition. And also we can define like a recursion as a technique of making a function call itself. So this technique, what is the use of this technique, is nothing but it breaks the complicated problems into simple problems. So we cannot some we feel difficult to solve a complicated problems, complex problems, where if you break them into small simple problems, then it is easier to solve them. Okay, so for that purpose we have a concept called recursion. Okay, the method involved in that particular process is called as a recursive method. So when it comes to the syntax of this recursive method, this is the syntax. Return type is nothing but a primitive data type. Okay, so if it is in front of any variable, it is called as a data type. If it is in front of any method name, method means with the parenthesis, it is called as a return type. Okay, so return type, method name. So in the method braces, we have code. In that code, if you specify the same method name, that is nothing but a method calling. So this is a code for method. If in the one of the statement as like calling a method, then that is called as a recursion process, and this method is called as a recursive method. Okay, so return type, method name, so code of the method. In that code we have a statement like a method calling and calling the same method. This is called as a syntax for the recursion. So this recursion are recursive algorithms, so based on the recursion concept. So there are so many problems solved by this technique. So for example, towers of Hanoi, in order, pre-order, post-order, tree traverses, DFS of graphs. Okay, these kind of all problems can be solved with this help of recursion or recursive algorithms. Okay, so if you go with an example, so we are learning about a Java. So we have a class, public class name. Access specifier. This is class name. This is, and in this we have two methods. So one is a p method, the second one is the main method. So the syntax should be like this only, and it is a compulsory method. Public access specifier, static without object we can call this method, and void return type. This method returns nothing. Main is the name of the arguments. The string arguments, whatever may be the input is given by the user or taking by the program, is always string. Okay, always a Java program treats any input given by the user, it treats as a string. That's why we are here presenting string arguments, string array arguments. Arguments is the name of the values we are passing, and it should be array. Array in the sense any set of set of elements. Okay, that is about array, and the data type should be string only. So that is the meaning of string arguments. Okay, so this is the main method, compulsory method. What we are doing here, we are calling p method. Where is actually p? Here. Okay, so before that we declare a variable count. Count is equal to 0, literal here. And what kind of a variable? It is a static variable. What is meant by static variable? Static variable is nothing but a variable, so which can be called by class directly, no need of any object creation. Okay, if you see here, so this method is a static method, this variable is a static method, that's why we are not creating object here. Okay, in the main method. Okay, so that's why, so without object also we can access them, that's why we are placing static here. And memory allocation also, so there is a difference with the memory allocation with the normal variables and these static variables. So only one location of memory is allocated for the static, whereas different locations are available for the normal variables, instance variables, where whenever we call them, different memory locations are allocated. But for the static, even I mean many times called, we have only a single memory location. Okay, so that is about a static. We don't want to recall once again. Okay, so static void p there. We have a count plus plus. So actually plus plus is an operator, right? So count already 0, plus plus means it will become 1. Okay, we have a condition here. So if count less than or equal to 5, already what is the value in the count? 1. So 1 is less than or equal to 5, less than, it's true. Then we are printing system.out.print hello count. What is there in count? 1. Okay, so that is printing hello 1. Okay, and again we are calling p. Okay, so from the main method we are calling p. So that is not actually called a recursion. So just now we discussed the definition. What is meant by a recursion? In which a function calls itself. A function calls itself is nothing but recursion. Okay, so here main method calls p, that is not actually recursion. So here p again calls p. Within the p method we are again calling p, that is actually recursion. So once again p called means what happened? So count incremented. Okay, so what is the value in count previously? 1. So now the value incremented by 1, that is 2. So 2 is less than or equal to 5? Yes, true. Then hello 2, print. So again calling p. 3, hello 3. Again calling 4, hello 4. Again calling. So 5, now the count value is 5. 5 less than or equal to. Okay, so till 4 we can check count variable is less than 5. Now the count value become 5. 5 is less than, we don't need, no need to check about less than. So we can compare 5 equal to 5. Yes, it's true. Then the condition, the statement will execute count hello 5. Okay, so again p calling. Again p calling means what happening? So 6, count value 6. 6 is less than or equal to 5? No, it's false. Then loop terminates. Okay, so this execution will terminate. Okay, condition false became, we can get out of the if condition. Okay, so then the process of calling will stop. Based on this condition, the process of calling is actually stop here. Okay, so like this, what is entirely what we are trying to say is, so p is a method. So in that one of the statement is calling a p, the same method. Okay, so method calling self is nothing but recursion. Okay, so based on this condition, how many times we call the method? 5 times. Okay, so if the condition is there, we can call the method limited times. So that's why I am specifying recursion example with a finite times. So if there is a condition, so then it will call only finite times. If there is no condition, that is actually called a infinite times. Okay, if you see here, so same example, we don't have any count and all everything for the previous and here. So class recursion example. So I just changed the names of examples. Okay, example, and 2 methods, void static method p and main method. In the main method we are calling p. So from here we are going here. Okay, so by the main method we are going to p. So in the p we executed hello, and after that again we are calling p. Again and again and again we are calling. Okay, we don't have any condition here. So continuously we are calling the same method, that is continuous of recursion is happening. Okay, so like this hello, like this the output will come. But the thing is, here here the system drives an exception, stack overflow. Okay, so stack overflow error, the program will rise. Okay, so what is this stack overflow? We'll see in the next slide. So till now what you understand? So method calling, the same method is called as a recursion. If we have a condition, it is called as a finite times of recursion. If we don't have any condition, this is called as an infinite recursion. Okay, So then what is that condition? That condition is also called as a base condition or halting condition. Okay, how, for example, if you take a looping statements like even of while, do, while, for loop, so there is obviously a condition exists in that particular, even in control flow statements, especially in loops. So if you take a for loop, while loop, do loop, so based on the condition, the loop will go on, right? So if the condition is true, then the loop statements will execute. If the condition become false, the loop will terminate. Okay, so how a condition is there in the looping, the same also here in the recursion, also recursion technique, that the condition is called as a base or halting condition. Okay, so what is this? A base or a halting condition is the condition where the function stops calling itself. Generally function calling itself is nothing but recursion. So to stop recursion, so we are providing this base or halting condition. Okay, it will stop the calling the method itself. Okay, so what the mean by this halting condition, what is happening is, so the base case is provided and the solution of the bigger problem is expressed in terms of smaller problems. Okay, so because of this base case or base condition, so we can exhibit the bigger problems into the smaller. How it is possible? Let's take a factorial example. Okay, so if n less than or equal to 1, okay, either maybe 0 or negative values, or maybe 1, so it will return 1. Okay, if it is a less than or equal to 1, it will always return 1. In any other case, so it will perform this thing. Okay, so what is meant by the number is multiplied with the fact of n minus 1. N minus 1, so the one number less than the number. Okay, so that is a fact. Is where is fact? The same method. Okay, recursion is happening, but the thing is they split the bigger problem into smaller problems. How it is? So calculating the factorial from 0 onwards, or 1 onwards, or maybe for every one, so for example, if n equal to 1, this is the factorial. If n equal to 2, this is the factorial. So that kind of things we are not performing here. Okay, so what you are trying to do is, if it is equal to less than or equal to 1, return 1. That is a base condition. So if it is other than this, if any number n values doesn't satisfy this condition, will go for else part. There the recursion will perform. So finally at the end we are coming to here only. So if this is the case, if at end if you satisfy this case, base case, it will return 1. What it mean? It actually we are stopping the recursion. Okay, so this base condition is used for stopping the recursion. Okay, n less than or equal to is the base case or base condition or halting condition for the recursion. Okay, so this base condition is used to break bigger problems into the smaller problems. If you reach this base condition, the recursion will stop. Okay, that is the thing. So here the same base condition is presented here, n equal to 1. Okay, so factorial, there we are taking less than or equal to 1, but here we are directly taking equal to 1. Okay, so class recursion example 3, main method we are taking, we are calling factorial method. So there we are going to factorial method. If n base condition, return 1, else we can perform this. Okay, so n into factorial of n minus 1. So what is n? 5 into n minus 1, 4. Okay, so that like that we are 4. Again we are sending the 4 value. Okay, so 4 value means again here equal to 1, no, then go with the 4 into factorial of n minus 1, that is 3. Again go again, so round and round. Okay, so like this, so a method calls the same method till the condition become true. This condition become true until the base condition become true. So if n equal to factorial of 1, if you want to find, then this base condition will become a true, then it return 1. There we can stop the recursion. Okay, So factorial of 5 is 120. So the same example can be explained in different way. So like this, so factorial 5 we have to calculate. So factorial 5 will going to call the factorial 4, factorial 4 will going to call 3 2 1. If factorial 1 is simply nothing but it returns 1. Okay, so until we reach the factorial 1, what is happening, factorial 5 is nothing but, so 5 into factorial 4. And what about factorial 4? 4 into factorial 3. And what about factorial 3? 3 into factorial of 2. So what is about a factorial 2? 2 into factorial 1. Again factorial 1 means returns 1. Like that this program will perform. Okay. So actually the problem can be defined in simple manner, I mean small problem, with the help of base condition. That is happened here. Okay, so now the thing is how a particular problem is solved by using recursion. Okay, so just now we discussed how these recursion will helpful in solving the problem. Okay, so with this recursion what we do is we split or break down the bigger problems into the smaller problems by providing base condition. Okay, so by providing the base condition we can represent a bigger problem into the smaller problem. Okay, thus base condition is used to stop the recursion. Okay, so in the previous example, so n factorial of n minus 1, factorial is the method, recursive method. So where base condition is nothing but n equal to 1. So if the n equal to 1 the condition reaches, we will return just 1 as a factorial. Otherwise we again and again call the factorial of n minus 1. Okay, two things happening. One is bigger problems can be represented in the form of smaller problems, and in the smaller problem is nothing but providing the base condition or a halt condition. By that halt condition what is happening, recursion breaks, actually breaking the recursion happening. Okay, so again one more example, Fibonacci series, all programs you know in C language, but here we are learning by using Java language. Okay, so count greater than 0, we are specifying a condition here. Okay, public static void main count variable 50, system dot out dot println n1 n1 n2 we are printing initially, and Fibonacci series we are calling. So count minus 2 we are performing. So count minus 2 why are pressing here, we took count as a 15, but already we are printing two values n1 and n2. Okay, so that's why we can start from third value. Okay, so that's why we are placing here counting minus 2. So for 13 times the loop will go on. Okay, so okay, so 13 times we have to perform the calling of fin fibo. Okay, okay, here static variables we are taking initially n1 0, n2 0. So we are printing n1 and n2, so that's why we have a 0 and 1 initially. Okay, so print fibo we are calling. So count actually we are passing 13 value. If 13 is greater than 0, yes, obviously 13 is greater than 0. So we are calculating n3 as n1 plus n2, that is 0 plus 1 1. Okay, so we are assigning n2 value to n1, n3 value to n2. So again we are printing the n3. So what about n3, n1, n2? So 0 plus 1 again 0. Okay, sorry, 0 plus 1 is 1. And we are passing the value of count minus 1. Count minus means so 13 minus 1 12. So like that we are gone till the condition become false. Okay, so count, if the count become 1 is greater than 0. Okay, if count value become 0, based on this condition count minus 1 continuously happening, then count value become 0. Is 0 is greater than 0? No. So 0 is equal to 0, that is correct, but 0 is greater than 0, that is wrong. Then we will stop the recursion. Okay, this is just like a count greater than 0 is just nothing but a base condition. Okay, So this is about a base condition or a halt condition which is used to stop the recursion. Okay. So why stack overflow occurs in recursion? So in the first slide, so we discussed about a stack overflow exception error like that. Okay. So what is it? What is it? If you didn't specify any base case, if you didn't specify any base case, or if the base condition is not reached, then the stack overflow problem may arise in your program. Okay, so then what is it? What is it means? Factor is, you can take the same example, fact. So fact, previously we took n equal to 1, right? Okay, so previously we took n equal to 1 here. Okay, but now what we are trying to specify here, 100. Okay, so if n equal to 100, then return 1, else we have to perform the same thing. Okay, so if the when we want to calculate factorial for 10, what is happening? So first we can go with the fact of 10. Okay, we'll pass like a 10, right? N value we have passed 10. 10 is called, it will called fact 9, it will called 8, 7 and so on till fact 1 we can call. Do we find anywhere n equal to 100? So when we will start 10, end with 1, but we never reach 100. Yes or no? So if it is 1, by calling 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, we'll reach 1, then we return 1 value. But if you specify 100 here, what is happening? So we cannot reach 100 at any time. Okay, so the base case is not reached. Okay, so if the memory, so if you can't reach this means, so you always calling and calling the same recursion is happening. Okay, so base case is not becoming true, then what is happening? So it will again and again performing the recursion, allocating of memory is happening, printing of data is happening. So the memory is exhausted by those functions on the stack. Actually how the these recursion values will store, will explain. Okay, it will cause a stack overflow error. Okay, so if we cannot reach the base case and the recursion will continues, then the memory become exhausted, means more memory space is required for calling method, printing data as well as the storing of a data. Okay, so this is nothing but the stack overflow error. Why it is called a stack overflow error means, so in the recursion, if you pass the if you call the factorial in this example, so first we call the factorial 5. Okay, again it will call 4, again it will call 3, again it will call 2, again it will call 1. Okay, so till factorial 1 calling, so what about the data 5, 4, 3, 2? So the multiplication 5 into 4 into 3 into 2 into, so this kind of a data where it is actually present, it is actually present in the stack. Okay, so stack, you know the stack memory locations, right? Okay, so first it will store the 5 value, next 4 value, next 3 value and next 2 value and finally 1 value. Okay, so after storing previous results, finally we will get the 1 and with this one we can multiply everything. Okay, so that's why stack overflow error is happening if the base condition is not defined or not reached also. Okay, that is the thing. So here is also happening, we don't specify any base condition, that means hello is printing continuously, so then we will have a stack overflow error. Okay, so types of recursion, basically we have a two types, a direct and indirect. What is direct mean? A function, for example fun is the name of the function, is called a direct recursive if it calls the same function fun. Okay, so one function calls the same function, then that is called as a recursion. For example, direct rec function, this is the name of the function. Here this is the code of this function. What we have done here, so we are calling the same function. Okay, so function calls the same function, then it is called as a direct recursion. So till now we see the same concept. Okay, now we have another concept, that is indirect recursion. Indirect recursion, a function fun, name of the function example, is called indirect recursive if it calls another function, say fun new. Two methods we are taking, two functions, so fun and fun new. So fun is calling fun new, as well as fun new calls the fun. Okay, fun calls fun new calls the fun, directly or indirectly. Okay, so then that is called as a indirect recursion. So here indirect, go with the numbering. So fun 1, fun 2. So fun 1 is calling fun 2. Here fun 2 is calling fun 1. Okay, so 1 is calling 2, 2 is calling 1. So this is called as a indirect recursion. Okay, here the same, so 1 is calling 1 only, like that we can think. Okay, 1 is calling 1 only, then that is a redirect. Here we have a situation, 1 calls 2, 2 calls 1, that is called as a indirect recursion. Okay, so then end of the recursion. So what is the disadvantages of the recursive program over the iterative programming? Iterative program means looping. We already completed control flow statements, there we discussed looping statements, right? So if we use any program by those iterative statements or a looping statement, then that is called as a iterative programming. Okay, so now you have a two programs, I mean you have a two concepts. One is a recursive program as well as a iterative programming. So you will check the both different, I mean advantages and disadvantages in between those two. So when it comes to the disadvantages of recursive program, so recursive means just what we discussed. Over iterative means already we completed looping statements. Okay, disadvantages of recursive program. So both recursive and iterative programs have the same problem solving power. Okay, both are equal. No differences at all. We'll see what is there in depth. So every recursive problem, even it is a factorial or maybe Fibonacci, just we saw some examples, right? Whatever the examples we did with recursion, all we can do with a loop also, and vice versa. Okay, so this can be done with the looping, and looping can be done with the recursion. Okay, that is good. So that means the same solving power. The recursive program has a greater space requirements than the iterative program, as all functions will remain in the stack until the base case is reached. So just we discussed now. Okay, so this is the thing. So until base condition factorial of 1 n equal to 1, it returns 1. Until we reach the base condition, previous results all will store in the stack. Okay, so we need space requirement, means more space memory requirements is required for the recursion programming, where is not there in the iterative programming. Okay, so we have to store the early results in the stack, and we have to wait for the next results. So it requires some more space requirements. Okay, that is the one drawback in the recursive program, and it also has a greater time requirements because of function calls and returns overhead. Okay, so function calling and returning, so it will get data from the stack, it will store the data into the stack. Okay, all these nothing but time requirements. So simply recursive programs take more memory as well as much time, like that you can tell. Okay, and when it comes to the advantages also there. Okay, so where we can provide a good way or simple way to write a code. Okay, so it is easy to understand the code if you write the program in the recursive program. That is the thing. And next one, so these recursive programming concept is a very much useful in a specific kind of problems like tree travels, towers of an eye and all. Okay, and those problems are specially need to write in the recursive program. Those cannot be possible in the iterative. I mean, even though if it is possible, complex to understand, but it is good to use a recursive program in the these kind of problems. Okay, it is very much useful, understandability and all. Okay, and uh, of course, yes, we have a we just discussed now, we have a we can solve these problems with the iterative also, but we need some specific special data structures like a stack. Okay, so recursive is good for the some older or inherent problems, or very complex problems like a tree travels 100 hours of HANA, but that is good. Okay, that's all for today.